For this video I'm going to look at the non-calculator paper which is June 2015. It's the higher paper. For those that are doing foundation, please do look at the first half of the questions, because a lot of those will appear on the second half of your foundation paper also. So I'm not trying to exclude any pupils at all from this, but you'll probably need to be, around about the grade C to enjoy doing this paper anyway. So good luck with it, and we'll see how we get on. Again, it's worth pointing out that the formula sheet, a lot of time has been spent putting this formula sheet together by different examiners. So, do use it where you can. Just quickly going over some of the main things that are here. We've got some ones that seem reasonably obvious, but you can refer to these in the actual exam paper. So if you know the cross section of something in terms of an area, be it a cylinder for example, it's really giving you an idea that if you can find one of the areas and push it backwards by a given length, and you can find its volume. Very handy one here, the area of a trapezium. So if you just think very carefully at what you're actually given, so if you're given a perpendicular height and you've got a pair of parallel sides labelled A and B, then you can just use this formula and work out the area of a trapezium. These are difficult, the ones involving the sphere, but they're given, and also the one involving the cone. Sometimes you may get the slant height referred to as opposed to the perpendicular height. Then we come to looking at, it says the quadratic equation, and one way of writing this is x is minus b over 2a plus or minus the square root of b squared minus 4ac over 2a. And the reason for writing it in that way is to notice that this will be the line of symmetry. For those that know, this will be the discriminant, for example. So if you see a quadratic form, you've got not just one way, but try and think of it in two ways, and you get the line of symmetry here for nothing. What else do we have here? Well, when it comes to trigonometry also, you've got the sine rule, one of the cases of the sine rule. Don't forget you can invert every part and have sine A over A is sine B over B is sine C over C if you want to find the angle first. And you're given one form of the cosine rule. Notice here that you've got Pythagoras here with a bit of a correcting factor. That's how you can look at it. And then you've got the area of a triangle as well. And a lot of students don't realise that if you've got a right angled triangle, and say you've got lengths here A and B, from earlier on in your school life that the area of that triangle is a half times the base times the perpendicular height. Now, what's different about sine C? Well, if you kind of look and think here, if you look at the triangle in question, in the right angle triangle that I've drawn, it's like saying C is a right angle. Okay, if you imagine turning this triangle around here to look like the one that we drew in blue down here. So really, all it's saying is that you can still write it as times sine C, where C in this case is 90, but for those that know the unit circle well enough, then the sine of 90 here is just 1 anyway. So it's actually giving you the formula for a right angled triangle as well. So don't be too off put by, half AB sine C. You've already seen it when you were very young, but you just didn't see it in that particular way. So that's enough of the formulae for now, and we can now get on and see what the paper has in store. So we need to complete an ordered stem and leaf diagram in this situation. So we'll put the stems in first. And I think there's a 1, 9 as well, good. And then, as it's ordered, what I tend to do is, I tend to do this again. And then just quickly tick the ones off that we have here. So 165, 164, 76, 79, and so on. And then I order them afterwards. So we've got a 6 with a 9, and then a 4, 5, 7, another 7, 8 and 9, and then in this instance 2, 3, double 6, 8, 9, and then 0, 2, 3, 8, and then this one's okay as it is. I would put a key as well to represent what the data shows. So I would say that represented 156, and I'd write key just here. And then it says work out the percentage of these men with a height greater than 184 centimetres. So this is where the stem and leaf can help. This is one of the reasons for doing it. So we can see 180, so greater than 184, so there'll be 1, 2, 3 men out of a total of 20. And then I suggest you can either times top and bottom by 100, and then halve to get 15 out of 100, or 15%, or you could start with 3 out of 20 again, and then times top and bottom by 5, which would give you 15 out of 100 straight away, which would be 15%, which would be the answer. Here we have to work out the value of an expression, 4x squared, when x is equal to 3. So first of all, let's look at what a wrong answer could be, and that is, so I write wrong here, and that would be doing 4 times 3, which is 12, and then squaring the 12 to get 144. That would be wrong. What 4x squared actually means is 4 lots of x squared, which is the same as writing 4 times x times x. So in this case, we want 4 times 3 times 3, and you can do the multiplication in any order now. So I'll do 3 3s are 9, times the 4 would be 36. In this next part, we're asked to solve a simple linear equation. So we want both sides to balance. So we want to isolate the x term. Generally, that's how we solve these equations. So I would take x off both sides, and that would allow me to have 4x plus 4 equals 14. Now I've got my x's here. On this side, I can take 4 from both sides, and that would then leave me with 4x equals 10. Now I have the x terms isolated, and I can now divide both sides by 4, because 4x means 4 times x. So I'll divide both sides by 4, and that would give me x is 10 over 4, and you don't have to cancel that down, but if you want to, you can write 5 over 2 by halving the numerator and the denominator. So we get x is 5 over 2. I think for this question I would be specific on a time scale, and I would ensure that my responses did not allow for overlaps. So let's have a look at the question. I would say, how many times per week do you use the BMX track in town? And then the responses, I would say 0 to 1, and then we'd have 2 to 3, so there's no overlap, and then 4 to 5, and then I would write strictly more than 5. And that would be nice and simple and not too complicated. Okay, so that's that question sorted. So in this question we've got to work out which place is cheaper to buy the 25 plants. So let's start with the first scenario. We would have 25 lots of £2.39. I think the way I would approach this is I would just multiply 239 by 25. So this is what we'd end up with. And you'd have your own multiplication method anyway, I'm sure. So 45, 33 and 4 is 37, 16 and 3 is 19, 4 and 1 is 5. And then I'd use estimation, and I'd say I'd roughly got 2 lots of 25, which is 50. So I'll be putting the decimal point here where it makes the most sense. So I'd have £59.75p here. And then in this situation, I would have a pack of 25 is £52.50 plus VAT at 20%. Well, there's a couple of ways of looking at this one. You could firstly say that 100% is £52.50, and then 10% would be £5.25, and so 20% would be £10.50, and then you'd add that VAT on, so you'd have £52.50 and £10.50, which is £63. So Kirsty's plants would be cheaper, and you'd probably write that in a sentence instead. Also, for the Hedgewild situation, you could do 52.5 times by 1.2, because what that means is you've got 52.5 times the 1 plus the 0.2, and if you times it by the 1, that's finding 100% of it, and if you times it by 0.2, you're actually finding the 20%, but then you're adding them both together to get the 120%, i.e. the whole amount plus the 20% more. So if you did 52.5 times 1.2, and I'd write this a bit better here, so 52.5 times 1.2, I never put the decimal point in, I always use estimation, so I've got roughly 50 times 1, so I'm looking for something around the 50 mark. And I do my multiplication, and you can do that however you want. I've got some videos on this multiplication method which you can look through. And so I'm looking for 63. So that's not too bad a question, just make sure you've got a good multiplication method at hand and understand about working out 20%. So let's have a look at the next one. The thing to do in this question is to work out the volume of the first type of cheese, so this one. Now I usually pick a corner and then I want to have the 3 directions and multiply those because that will give me the volume. So I have 15 by 2 by 10. So if I multiply those, that will give me the volume. So I'll have 30 times 10, which is 300 centimetre cubes. And then the new cheese will be also in the shape of a cuboid. Oid means like, so cuboid is like a cube or of a cube. And the cross section of the cube will be a 5 by 5 centimetre square. So if this is 5 by 5 and you look at your formula sheet at some point, you'll see the area of a cross section times the length would be the volume. So if you picked a point here, for example, you would have x times by 5 times by 5 would give the volume, and that would be, well, you wouldn't say x25. That's definitely, I've seen that enough times on papers where people do that. That's not good. You would say the number first, 25 lots of x. Now it's got to have the same volume as the one before. So if you think about it, these would have to be equal. So you'd have 25x would be equal to 300, and then I would divide both sides by 25, and how I'd have x is 325ths. Now to me it would be contentious to see whether that would be acceptable for the 3 marks, but I think on the mark scheme it would probably expect you to cancel that down. So I wouldn't worry too much about that. If you just try and make the denominator 100, so you could double out of trouble. So you could double the top and double the bottom, then cancel through by 10, and that would give you 65ths. Now you either know 5s into 60 is 12. If you don't, you can double out of trouble again, double the top, double the bottom, divide by 10, and you'd get the answer of 12. So that would be 12 centimetres. So I think, forming the equation is difficult enough for some people, and then they feel they've done a good amount of work to get to here. For me, 325ths can be cancelled down, and it is a whole number. So I think the exam scheme, mark scheme, will be looking for that number there here, 12. Okay, next question. Now I've given good advice on these before in previous papers that I've looked at and done with you, and the first thing I would do is I'd get my straight line, my line of best fit, sorted out first. So let's put that where it goes through the middle of the flow of points that we have. So that's good enough for me. And it says describe the relationship between the age of the car and its price. Well, in this instance, I would say as the age increases, the price of the car decreases. So sometimes you can use your common sense here, but some of you might think, well, if it's a vintage car, if it gets older, then it will go up in price. But these 12 cars are obviously not anything special. They're depreciating as their age goes up. So that's the correlation, it's a downward trend. You can also say strong negative R correlation, and that would be fine also. Now, you could say the newer the car, the greater the price, for example, but you want some form of dynamic relationship, and dynamic means between two variables, so they've got to have a strong relationship, and you've got to explain that. So you could say the older the car, the lower the price, for example. So let's have a look at now the last part of the question. So this asks for a different car of the same model is 3.5 years old. Estimate the price. So let's go back to my diagram. Let's get this line of best fit looking accurate. So we want 3.5 years. I'd use your ruler and join these points up carefully and then read off the scale. You have to do this, and then you would get, right, so let's have a look, 1, 2, 3, 4, 5, 6, so I'd say £6,600, and then I'll just put my answer where it needs to be. So that doesn't seem too bad. I think the tolerance would probably be on the mark scheme somewhere between 6,500 to, I don't know, 6,900. It could be wider, but 6,600 definitely get you the mark. So this question's not been very easy to set up, but I just want you to look at what's happening. You can use tracing paper for rotations. So I've made this go anti-clockwise, and we're going to just have a look at when we begin. So we're coming up to where we start, so there we started, and then we're turning, and then we've got to 90 degrees there, and then 180 degrees there, and then 270 degrees there. So I'm going to start marking these off in a minute. So there we go, we've started there, and now we're turning the page, and it's 90 degrees just there. So we had something going on here. There we go, another one there, 180, and then another one here at 270. So let's look one more time. So we have our points there. There's our first one. I missed the second one. Here's the third one. And we're going to get that second one. So that's the 90 degree turn. And then there we have it just there. So that's the 180 degree turn. So the one we wanted was this one here. We don't need the others, so I'll just put this in a colour here just so you don't get confused and put the wrong answer. So that's going to be 90 degrees anti-clockwise, okay, this way. So let's move hastily away from that one because that was very difficult to set up. So this question, we want to describe fully the single transformation that maps triangle B onto triangle C. So one nice thing to do is to look at a point on B, look at its corresponding point on C, join the 2 points up, and then you can use tracing paper in this situation, because all I'm going to do is I'm going to try and test to see whether a rotation is correct. So I'm just going to join all these points up. And then what I'm going to do is I'm just going to set a rotation to happen. Hopefully it's going to work. So I'll have the point around here, and let's have a look. So if I turn this around, then hopefully you'll appreciate that if I've turned it, I can make it seem to fit, but can you see there's an overlap? It's not quite going to work. There's going to be this overhang here. Okay, so a rotation, I'm afraid, is not going to be the answer. Well, is it going to be a reflection? Well, if you've noticed that if you look at B and see the corresponding point C, then they're the same distance away from the origin. In fact, if you looked at this point here and this point here, then there will exist a line somewhere. So if I join these 2 points up, this may help you. Can you see that they're the same distance from this point here? And likewise, if I try this one without messing it up, let's join these up. They're the same distance from this point, say here. Okay, started here, end up here, and we're the same distance from here. Now, one thing I'm going to try and do is draw a straight line which could act as a mirror, and let's see if I can get that right. So let's say this is my mirror, and if I put it here, you should know that the gradient of this line is for every one I go along, I go up the same amount. So if I go along 2, I'm going up the same amount. So hopefully you're aware that this is y equals 1x or y equals x, and I'm not going to be adding anything here to the intercept because it goes through the origin. So I'm just going to be left with y equals x. So that seems to be the mirror line, and all you have to say to yourself is, does B see itself in this mirror to get to C, which is the image, just like an image in a mirror? So to answer the question at the end, I would say very clearly that the transformation is a reflection in the line, and just give its equation, the line y equals x. Okay, so that's that question done. Well, this question's not half as complicated as explaining the answer to question 7, that I can say. So let's have a look. We'd have the simplification of an expression involving terms in G and H. Now, with this expression, you have 6 lots of G, and we want to take away 4 lots of G. So if you think about it, 6 lots of G with 4 lots of G taken off is going to be 2 lots of G. And then if we started off with minus 5 lots of H and added 2 lots of H, well, that's the same as doing 2 lots of H with 5 lots of H taken off, which would get you down to minus 3 lots of H. So what you've really got left in this situation is just 2G minus 3H. With this question here, factorising, write the y squared term as y times y minus 2 times y, and then just circle a common factor, in this case y. Now, when I wrote this out like so, it doesn't matter which one you circle here as long as you only circle one of them. Okay, so in either case it's fine. You're going to get from either situation here y coming out as a common factor, create your bracket, and then you've got y minus 2 left. And if you want to check, you can just multiply it out and say, right, y squared minus 2y. So the answer we're going to write down here is y lots of y minus 2. Now in this one we want to simplify fully. So on the numerator we've got p times p times p multiplied by p times p times p times p times p. So how many of these do we have? but they're all to the power 1, and the rules of indices say that we add the powers, so we'd end up with p to the power 7. And underneath we just have p squared, and then p squared, I didn't really need to do that step, we end up with p to the power 2. So what I want you to think about is, if I go backwards here and then just write p times p underneath, what's effectively happening is we're cancelling off these terms and we're just left with 5 powers of p left. Or use the rule and just take these away and you'd be left with the answer p to the power 5. I think these questions are some of the trickiest questions in the paper. There's a lot of words, so easily to get confused. You've got to realise there are 40 pencils in a box and 15 pens in a packet. I'll just underline those. So you don't want to be having pens and pencils left over. Okay, it says there are none of them left over. So I think the most logical thing to do, and this is practice, when you see these kinds of questions you'll realise what to do if you do enough of them. If you look at the pencils situation, they come in 40 in a box. So if you just do the 40 times table, just carry that down a little bit, and then do the same for the pens, and there's a reason behind this. So 1 packet and then 2 packets and so on. Just keep going. Now you might wonder, well, how far do I keep going? Well, what you're trying to do is you're trying to get the numbers in each of the columns to match up. Okay? And that's all about finding the lowest common multiple, but you don't need to know that situation. Just try and use your logic. So if that is 1 pack here, and then 2 and 3 and so on, and then here, then basically what's happening is we can see that the first time that these numbers coincide is here. So what it would mean is that if he gave out 3 boxes of pencils and 8 packets of pens, this would be one of the conditions that would be acceptable. So you could say 3 boxes of pencils, 8 packets of pens. But that's not all you could say. There could have been more. So you could have carried on the times tables and the numbers would have been the same again. But as long as you haven't got any pencils left and no pens left over. So in this question we have quality of written communication again. So we're going to set our work out well. And we want to work out whether £100 is enough to cover the cost of tiling the floor. So let's split this into 2 shapes here. Let's get that better. So we've got a trapezium here, and then we've got a rectangle here. So first of all, let's try and find the area of the rectangle, the easier one. So we've got the area of rectangle would be 3 by 2.2, which would be 6.6 meters squares. And then the area of the trapezium, well, that would be the sum of the 2 sides that are parallel to each other. It's always the case. So you've got 3 plus the 1, which is 4. Now what I'll do is I'll just write that out in the step here. So we'll have 3 plus the 1. And then what we do is we times by the perpendicular height between them. So in this case, this length here, which would be the difference of 3.4 and 2.2 given on the diagram, which would be 1.2 metres. Now, if we times the 1.2 by the 3, that would give an area. So if I did 1.2 by the 3, that would give an area that's too much. If I times the 1.2 by 1, so the 1.2 by 1, that would not give enough. It would give this area here. So what we do is we find the average of those two areas, and that will always be the area of the trapezium. It's basically one side times the perpendicular height is always going to be too much, the other side times the perpendicular height is not going to be enough, but on average that's how you find the area of a trapezium, and that's why the formula is what it is. So we've got 1.2 lots of 4 divided by 2. 2's into the 4 is 2, and so we've got 1.2 times the 2 is 2.4 metres squares. So the total area is going to be 2.4 and 6.6, which is 9 metres squares. And now we can look about how we're going to tile the floor, and are we going to have enough. So one pack will cover 2 metre squares. So the first thing to look at would be how many packs of tiles would we need. Well, if we've got 9 metre squares, so tiles now, this would be 9 divided by 2, which is 4.5. So we'd have to buy 5 packs for sure to have enough. A pack of tiles costs normally £24.80. So the cost of 5 packs, that will be 5 times 24.8. So I would do a multiplication grid. And so we've got 40, 20 and 4, and then 12. And then I'm using my estimation, I'm saying 5 20s are 100, so the answer would be £124. So that will be the cost. And you can do your multiplication by hand however you want to do it. And then she gets a discount of 25% off the total cost of the tiles. And this is where you can go into having a different approach. So once you've got your cost of 124 before the discount, there's a couple of ways that you can find the discount without a calculator. If you get 25% off something, then you really have 3/4 or 75% of it left. So one way you can do is just to times 124 by 0.75, and that will instantly reduce it by 25%. Or you can do 3/4 of 124, because 3/4 is exactly the same as 0.75. In this case, I think that would be my preferred way. We can see here that 4's go into 12 3 times, and the 4 goes into the 4 once. So we've really got 3 times 31, which is £93. That's with the discount taken off. If you wanted to find 25% of 124, you can say 100% is 24, 10% is £12.40, and so 20% would be £24.80, and 5%, if we halve this one, will be £6.20. So 25% would be these two added together. So this gives you the pound, and so you've got £31. And if you take £31 away from the 124, then you've got 3, and 12 take away 3 is 9, and that leaves you with £93. So yes, I would say Mary did have enough money with the £100 that she had. And so there are many different ways of approaching this problem, but that's just my view on it. So good luck with that question. So this question has an awful lot of words, which can make it seem quite ominous to start with. But if you just try and think that the dice, it should really say the word die, that's the singular, but the dice is numbered from 1 to 10. Each person will roll the dice once. A person wins the game if the dice lands on a multiple of 4. Well, if it's numbered from 1 to 10, then the 4 times table is only going to be you win if it lands on a 4 or an 8. Now, out of those 10 choices, you've only got those 2 choices of actually winning. So 2 out of 10 chances, or 2/10 of the time, you'll pick a multiple of 4. That's what's expected. So I would say the probability of Ali winning the game is 2 out of 10, 2/10. Never write in the exam 2 out of 10. Always write it as a fraction, either cancel in its lowest form if you want, although this is fine, or a decimal, 0.2, or as a percentage, 20%. So 2/10 as a fraction. It then says each person pays 30p to play the game once. And it says the prize for a win is £1, and Carl thinks that the game will be played 100 times. So this is like relative frequency. So if you expect to win 2/10 of the time, and you play the game 100 times, then you'd expect 2/10 of the time to win. Now, if that's 100 events or 100 trials, then we've got 2/10 of 100. Now, cancelling, if you treat it like a fraction question, like so, 2/10 times 100 whole ones, then you can cancel 10s into 100 is 10, and you've got 2 times the 10 is 20. Now what that means is that's how many times someone would expect to win if the game is played 100 times. So you can clearly write there 20 wins, therefore you would have 20 times £1 paid out, and that would be a total of £20 paid out. But if it costs 30p to play the game once and 100 games were played, then your revenue, what would come in, would be 100 lots of 30p, which is 3,000p, which is £30 revenue. So, what would be the net effect? How much would he raise for charity, assuming that he gave all the proceeds to charity? Well, if £20 is paid out and he receives £30, then £10 or 1,000p would be given to charity. So now we have to be careful with our explanations and how we write them, because of the quality of written communication. Now, I'm not necessarily going to write everything out as I would be doing a paper. I want you to be able to understand how to do the question as well. So it says work out the size of the angle marked X. Well, the first thing that we can look at is look for types of angle property that help us. So we definitely have angle. I used this symbol for angle. Angle BEF equals 60 degrees because we have alternate angles, 3 syllables, 3 strokes of the pen. So I'll do that one more. Alternate. And there we go, there's 60 degrees. So we can say because it is alternate to angle ABE. So if we know that was 60, then we really do know this one because we've got 80 and 60 and we've got angles on a straight line. So 80 and 60 are 140, so this angle here is 40. I think we need to make sure that we write enough information, because when we get from the 40 here, then look, we can use alternate angles again, and therefore x is the same. So first things first, angle FER is 40 degrees because angles on a straight line sum to 180. Also, angle QRE is 40 degrees because it is alternate to angle FER. I find these questions just a little bit dry, to be honest. You know, it just takes far too long to write the stuff out, and it's quite obvious to see sometimes what they are. You know, you have to have a balance, I suppose, but I do think this is overdoing it a bit. So I would say, therefore, x is 40 degrees and get away from this question as fast as possible. I think what this types of question give you is some kind of discipline to like slow down and get everything down on paper. But I know that some people's minds rush ahead and they do fall short on these things, so you really do have to either save this type of question till the end, or make sure that you don't rush through it and miss out information. I think when I looked at this question for the first time, i.e. 5 seconds ago, I looked at the shape and my eyes started to spin. So I'm just looking at it again. 8-sided shape, that's fine. 4 rectangles, 4 congruent right-angled triangles. Oh, and I'm glad it gives the measurements here. So if we just look at one particular measurement, then we've got 8 here. This is 2, so this must be 6. Okay, so I think the first thing to note is we can find this length here, because if we take one of these right-angled triangles, you might have heard of something called a Pythagorean triple, i.e. if this was 3 and this was 4, this would be 5. It works as a nice whole number. There are other ones as well. So 3 squared is 9, 4 squared is 16, and 5 squared is 25, which will go off the page. But basically, the two smaller areas make the larger area, and a Pythagorean triple is something where there's a nice integer value, say 3, 4, and 5. I think another one that I know is 5, then 12 and 13, because 5 squared is 25, 12 squared is 144, and if you add 144 to 25, you get 169 for the hypotenuse area, and so the hypotenuse length would be 13. There are many others. I think 7, 24, 25 is another one. But what the point is I'm trying to say is, if this is 6 and this is 8, then this length here would be 10. And the only reason I know that is for experience, but you'll see it now, that if I multiply this scale factor by 2 times this length by 2 and do the same to this length, then I have to do the same to that length. So you can check that 6 squared plus 8 squared is actually 100, and that gives you the length here. So I think what I would probably do is, for you, if you were doing this in your exam, I'd probably not mention Pythagorean triples too much, but I would probably just draw the right angled triangle as shown, the shaded one, and just say if this is 6, this is 8, then 6 squared plus 8 squared gives you 36 plus 64, which gives you 100, and so this length is the root of 100, which is 10. So we know all the gradients now for finding the perimeter of the 8-sided shape, because we know for sure that these lengths are 2. And then we've got basically some 10s here. So I guess a quick way of doing is to say the perimeter is 4 lots of 2. These ones here, 1, 2, 3, 4, plus 4 lots of 10, which we've just found. And that gives us a nice answer of 8 plus 40, which is 48, and the units are centimetres for perimeter, because we're walking from one point all the way around to the start again, which I'll just finish off now I've started. Okay, so it looked harder than it was, but you had to kind of look for the Pythagoras there because it wasn't really jumping out at the page. So anyway, not too bad a question really. So in this question you've got to be careful. It says she leaves at 10 in the morning here and travels at an average speed, so over the distance of 10 miles the speed is 40 miles per hour. Now this is a distance of 10 miles, so if you look at the units here, 40 miles per hour, then what we can start to look at is we can start to look at this and say, okay, then that would be 20 miles in half an hour, okay, and that will be the same as saying 10 miles in, well, hopefully you can work this out, in a quarter of an hour. So what did I do each time? Well, to get from here to here, I halve the top and halve the bottom, just like you would a fraction to make it equivalent. And then here I did exactly the same again. So I've actually got my 10 miles and the time taken a quarter of an hour. So 10 miles, that is 1/4 of an hour, and 1/4 of an hour is 15 minutes. Careful not to write 25, because that would be a quarter of 100, and there's not 100 minutes in an hour, there's only 60. So 15 minutes. So started left fullback at 10, now it's 10:15, got to be there by 10:35. So basically from 10:15 to 10:35 is 20 minutes remaining, and has got to go 18 miles in 20 minutes. So if you have to go 18 miles in 20 minutes, well, that's miles per minute, but you want to convert it to miles per hour. So think to yourself, 20 minutes is what fraction of an hour? Well, it's a third of an hour. So you're going 18 miles in 1/3 of an hour, which is good because all you have to use is your common sense and say, if I times the top and bottom by 3, just like you would a fraction, then what you end up with is 54 miles in one whole complete hour. So using the dimensions of miles per hour, you've now got 54 miles per hour. So that's personally how I would approach this question, not make it too hard. But what you're looking at here is not a formula triangle or something like that to help you remember, but you just got to interpret what it says here, miles per hour, and this is called the dimensions of the problem, i.e. the units that we use. And the units we've got here is M for miles and H for hours. Okay, so miles and hours, and that's what you've got to get it into. So whatever you do, you just read the question, get the units, and if you've got miles per minute, that's fine, but you've got to get it into miles per hour, and you can just do that conversion. So it's just about, using your number skills to try and make it per hour, and then you're okay. So 54 miles per hour would be my final answer there. So if we've got two coordinates, A -2, 4, and B 8, 9, you can't always draw the points to scale, but you can sometimes have a rough idea of where they would be. So you could have an XY pair of axes drawn, and then you know that -2, 4, A would be up here somewhere, and you know that B is 8 along and 9 up, so you probably know roughly it's up here. So all you have to really do is to draw these two so they meet, a little line segment there, and you just want to basically go halfway along from one starting point, so halfway along and then halfway up, and you'll end up here. And the best way to do that is to do the mean or the average of the y and x coordinates. So if you do -2 and 8, which is the x coordinates, I should say ordinates, and then halve them, that's the mean of those, so that's the mean of the x's. And if you do the mean of the y's, then you'll have 4 and 9 halved. Well, in the first situation for the x's, you'd have -2 plus 8 is 6, divided by 2 gives you 3, and the mean for the y is 4 and 9 is 13, 13 over 2, which is 6.5, which, it's fine to say 13 over 2. So basically, if you moved along 3 units here and 6.5 units up, you'd be at this point here. And if you think about it, to go from -2 to 8 is a distance of 10. So if you did actually go halfway along from -2, i.e. up 5 units, you'd be at 3 by the time you got there, because that distance here would be 5. And this distance here would be 5. And then once you're at 3 here, well, how far have you got to go up? Well, if you're starting from a y ordinate of 4 and you're going as high as 9, then the distance between 4 and 9 is 5, which is 2.5 units up here. But you started from 4, and 4 and 2.5 is 6.5. I think basically you have to use a bit of common sense, but if you do the mean of the x's and the mean of the y's, you're always going to get the answer. But a nice little diagram can help as well. So let's put that as our answer. That's how I'd leave it. In this next part, we've got QWC again. It says D is the point with coordinates 100, 56. Does D lie on the straight line that passes through A and B? So there's going to be a whole lot of ways of being able to do this question. And first of all, we're going to try and look at what the equation of the line would be. That's one method. So if we know it goes through -2, 4, and it goes through B, which is 8, 9. This is just one way of doing it. We could say the gradient is the change in y, So we can do 9 minus 4 over 8 minus 2, or we could do it the other way round, as long as we do it the same for both. So we could have had 4 minus 9 over minus 2 minus 8. Either instance would have got either 5 over 10 or minus 5 over minus 10, and they both give a gradient of a half. So some students know this formula, and that is y minus y1 is equal to mx minus x1. And if you know that formula, and I've got a video exactly on that formula under straight lines, so if you're happy with that one, that's quite nice, because you can put in any point you want, either the a coordinate or the b coordinate, as x1 and y1, and then you've already got the gradient now. So you could say y minus, and we'll go with the b coordinate, so y minus 9 is going to be equal to the gradient, which we know now, a half of x minus, well, the x coordinate, which was 8. So that's the formula, which again, watch the video for that. You probably will understand it, it's not too bad. And you put the numbers in that you know, and then what you can do is you can times everything through by 2, so you'd have 2y minus 18 equals x minus 8. So 2y would be x, and you add 18 to both sides, plus 10. And if you want, you can just divide both sides by 2, and we'd have y equals x over 2 plus 10. Now, if you're really good at doing that, and you're quite good at straight lines, it's not too much work then to check whether 100,56 is allowable. Because if you put y as 56 in here, and x as 100, if you get them balancing, then that would be true. The line would go through that point. But in this case, you can probably see that 100 divided by 2 is 50, add the 10 is 60. And there's no equality there, so that means that point is off that line. Okay, so that's one way of doing it. So you can then say, I'm not going to write this, you can say D, the point 156, does not lie on the straight line that goes through A and B. That takes far too long for me to write out. But I want to show you another method of doing it. So one other way is, you know that if A was negative 2, 4, and B was 8, 9, then you kind of have this idea that you've got the gradient. So we'll stick with this gradient being a half. That's important. And what that means is, if you have the situation where you've got the line, it means for every 1 unit you go along, you go up by half as much. So if you went along by 2 units, you'd go up by 1. And that's one way of looking at this. That's what you go along by, and this what you go up by. So that takes experience to work out. So 1 along, a half up, 2 along, 1 up. So what you could do is, you could say, well, if it's 2 along, 1 up, then surely it's 20 along, and then 10 up. So you could go from a point you know and say, well, I'm going to go 20 along, so I'll be 28, and then 10 up, 19, and that would be okay. But then surely that means you could probably go 40 along and 20 up, because the ratio is still a half. So you could add 40 to the 28 and get 68, and add 20 to the 19 and get 39. So if we went another 40 along and 20 up, we'd end up on 108, 59. Now that's really close to 156, but if we just started to get our way down to 156 if we could, then would we be able to manage it? So if we went along 4 and up 2, that means we could go back 4 and down 2. So think about this. If I could go forward 2 and up 1, it means I could go back 2 and down 1, or back 4, down 2. So if I start from here, and on the x, I go back 4, it means I've got to go down 2 here. Now I'm getting really close to the point D, but am I going to be on it? Well, if I go from here and I go back 2 and down 1, then the closest I'm going to get is the coordinate 102,56, but I'm not going to get 100,56. So you don't have to do it such a long-winded way. You could have just started from one of these and gone up 80, say, for example. So you could have gone along 80 and up 40. As long as the ratios are half and you're following the gradient rule, that's absolutely fine. The last way that comes to mind, and like I said, I'm just trying to do as many ways as I can because you're all different types of thinkers. So method 3 could be you start with a point that you definitely know, one of these, and then you put your point that you're trying to test down on paper, and you say, well, okay, if it lies on the line that goes through A and B, then if I compare A with D or D with B, the gradient between those 2 points should be a half as well. And if it isn't, then D doesn't lie on the line that goes through A and B. The rule for the gradient must stay the same because the line's not going to suddenly bend. So why don't we make the numbers the easier ones, the positive ones? So we'll just compare coordinate B with D. So we'll look at the gradient, and that's the change in the y. So we can do 56 minus 9. Don't forget you can do 9 minus 56, but we'll just do this way for now. 56 minus 9 over 100 minus 8. And then 56 minus 9, well, that's 47. And 100 minus 8 is 92. And that does not equal a half because you'd have to be 46 out of 92 to be a half, because 246 is a 92. So as long as you showed your working out, you'd be okay. Now I have to say, straight lines are very, very difficult for students to pick up, and it's quite hard for teachers to teach as well. But the nice thing about straight lines that I always say to my students is they're very, very predictable, because they just go in one direction and they just carry on forever. They don't suddenly change direction. So if you can keep that in your head, then they're not quite so scary. So in this question, you've got to complete the cumulative frequency table. Now, cumulative frequency, if you accumulate something, you gather something over time. So if you think about gathering the frequencies up so far as you go through, so you're starting with 20 to 30 minutes, for example, and you're gathering 4 as a frequency, so that's how much you've got to start with. By the time you get to the next class interval, these being the class intervals, you've got how many frequencies so far? 16 more, so that's 20, and then 36 more, which makes 56, and then 24, that's 80, and 14, that's 94, and then 6 more, and then just double check, is that the same as we've got here? Yes, it is. So always check that out. So I think to accumulate, to gather the frequencies up as you go along, that's a good way of remembering it. And then it says, on the grid, draw a cumulative frequency table, a cumulative frequency graph for your table. Right, so let's see what we can do here. So somehow I managed to cut and paste another slide into another slide, so I've managed that, so I feel good. And let's have a look. Use your graph to find an estimate for the median time. Well, when we're looking at median, think about the quartiles. So the first quarter or the first 25%, we want to get to the second quartile or the 50% mark. So that's halfway. So we had 100 people, and we're going to be using the median. So first things first, let's plot the cumulative frequency curve, which is called an ogive, O-G-I-V-E, ogive, and let's see what shape that has. Now we're going to plot the cumulative frequency definitely, but against what? Well, I always tell my students that if you're accumulating things as much as you can in each class interval, you're going right to the maximum end point each time. So you've gone from 30 and you're plotting that against 4. So 30 against 4, well, if that's 10, then 4 is here. 20 against 40, so let's have a look. So we've got 40 on the time, 20 on the cumulative frequency. So 40 along and then 20 up is here. And then 50 along and 56 up. So 2, 4, 6. Be careful of the scale. It's not that easy. 60 along, 80 up. And then 70, 94. And then 80, 100. Then let's have a look if I can manage this. Like I said to you, try and draw your smooth graph by drawing underneath the points. So let's try these bits first. So a steady hand. Okay, then I'm going to turn the page and complete these ones here. So let's have a look. Now, just looking at the question, and cumulative frequency is definitely not my strength, I have to say. I'm just thinking, as you can't actually be 20 minutes here, I would say there'd be nobody at 20, so I'd probably join that one through here. So that's that finished. Use your graph to estimate, to find an estimate for the median time. Well, there's 100 people in the fun run, so if we go to the middle person, the 50th, even though strictly there's 50 people on one side and 50 people on the other, the median is strictly the 50.5, but you just read along to halfway. So if you go to the 50th so far, here, and then you should use a ruler and just basically go along to your ogive and then read downwards. You end up with around 49 minutes. Now I would definitely write 50 here, just so the examiner knows that you meant to be at 50, because you may get this out of the range of what it wants, but you'd get the mark for starting off with the best intentions at 50. It says, use your graph to find an estimate for the number of people who took longer than 63. So again, if you read along at 63 here, which I should probably enlarge this, to be honest. So let's go along to 63 here, and let's do a dotted line or a thick line, it doesn't really matter, up to here, and then read along carefully. So looking at that and being really careful here, it looks like 82, but it's not, it's 84 because 90 is here. Be really, really careful with the scale, just really take your time, because you can think you've done it perfectly correctly and then end up with not as many marks as you thought. And this is the kind of questions where the marks can go really easily. So I would say at the 84th person, so it's going to be the 84 or more, so I would say 16, as there was 100 people on the fun run. So I would say, the answer to the question, the number of people who took longer than 63 minutes would be the remainder. So I would go with 16 people. Okay, so anything else to check on that question? Let's just quickly go through it. Cumulative frequency done. The ogive is nice and smooth, which is fine. I've got my median, and you definitely need to check that you've shown how to find the values. You can't just look along with your eyes and assume that the examiner knows you've done that. So you must show those lines on the graph. Okay, so that's that question done. I think for this question, we've got to work out the size of angle DCF. So DCF. So this one here. I'm going to enlarge the shape a little bit, and that might give us a better view here. So let's look at the centre. So the centre is going to be around about here, and I'm just going to draw from a vertex C to the centre here, and then to D. Let me get this right. Okay, like that. Call this O, and then I'll do another one here, I think. So, first things first, I know that these angles here, so I know that angle COD is 360 degrees between 5, because there'd be 5 of these coming off. Okay, so each of these angles will be a fifth of a whole turn. And if I don't know that, I can just double out of trouble and say that's 720 over 10, which is 72 degrees. So I know that's 72 degrees. Then I know that this is an isosceles triangle, so I can say triangle OCD is isosceles. And therefore base angles equal, and they will be 180 minus 72 halved, because they've got to share what's left from 180, which is 108 halved, which is 54 degrees. So these are 54 degrees here. And then if they're 54 here, then by symmetry, this angle here is 54, and this angle here is 54. So what I'm thinking is that if this centre angle here is 72, then this centre angle here is 72. And then I'm just going to have a look at the diagram for a minute and see if I can see anything else which is clear to explain. Right, I've just seen something here. If we go from here to here, and then to here, and then to here, I can see what is referred to as a Z angle, which you're not supposed to ever say, but it looks like the Z angle because this line here, if I draw it in purple here, is like having a pair of parallel lines here. And if I go over this again in a different colour, you'll see what I'm saying. You can see that if I go from here to here and then to here, then my reason that I can write is I can say that angle B, this was B here I believe, we can say BOC equals angle OCF because alternate angles, and I can say therefore angle BOC is angle OCF is 72 degrees. But the nice thing about this is that this angle here, don't forget this was 54 just up to there. This angle that we want here is going to have to be what makes 54 turn into 72, because don't forget we've said they're alternate to each other, so we're saying this is 72, so all of this is 72. So therefore we can say angle DCF is equal to 18 degrees, because that's an upside down therefore sign, so because angle OCD plus angle DCF equals 72 degrees. So at the end of the day, we've got the angle in question is 18 degrees, and it's taken a fair amount of explanations to do it, but as long as you show the examiner your train of thought, it doesn't have to be perfect the way you write something out, but just show them what you're thinking and show the steps, then you should be okay, because they've just got to award 4 marks. They just want to see enough. So lay your work out reasonably well. It doesn't have to be completely neat, but just show what you're doing. And that's the end of that question then. Now I think these questions are quite tricky, but I think the best thing to do is just say that they are equal. I'm sure some teachers would be shouting at me if I said that, but let's just say that they are equal. And let's sort this one out first. Let's take x from both sides. And let's deal with this one first. This is the one that will scare most people. And we would see the intercept is 7 and the gradient is -1. So what does that mean? We go along 1, down 1, along 1, down 1 from any point that's given. So we're given this, so we go along 1, down 1, and we can at least carry that on. We only need 2 points to plot a straight line, but what I'm saying to you is there's all of them, and I'll create this line now. Hopefully I won't mess it up. Let's have a look. So we'll do that, and we'll put all those points so they match up to the line. So there's this one, and we can label that as x plus y equals 7. That's perfectly allowable. Now we'll pick on this one here, y equals 2x. Well, y equals 2x plus 0, so the intercept is 0, and the gradient is 2. So for every one I go along, I'll go up 2 this time. So if I went along 2, I'd go up by 4. 1, 2, 3, 4, and so on. So I'm going to draw a line that goes through that one now. Let's have a look. And line that up without messing everything else up. Let's have a look. So there's that one, and I'll label that y equals 2x, and then finally I'll have y equals 3. So y equals 3 just means no matter what x is, y is 3, so all the way across here. So we'll find a final line here. Now if you've got the idea, then just please skip the video, but if you don't, then carry on watching. So there's the line y equals 3. Now we're going to do the interesting bit. To start with, you can probably guess that this is the region, but let's not do that, and let's just try and work it out. So we're now going to say, okay, let's shade in exactly what the inequality tells us to shade in. So I'm going to choose another colour, and we're going to have a nice orange. So we're going to do y is greater than 3. So we're going to take the line here, and we're just going to shade all of that greater than 3. Okay, now we're going to take the line y is 2x and go everything less than that. So we're looking at the line y equals 2x, we're going everything less than it. So here we go. And when you're in the exam, you obviously won't have all these coloured pens, just shade in a different direction. Okay, now we're going to leave the most difficult one till last. So we'll go back to this colour, and if x plus y was equal to 7, and I took x from both sides, then if we had x plus y was less than 7 and we took x from both sides, we would have y is less than minus x plus 7. So all it means is we go to the line y, x plus y is 7, and we just shade in everything underneath it. That's all you do. We just follow the inequality sign. That's why I always would get them in the form y equals mx plus c every single time. So let's have a look. Let's choose another colour that we've not chosen yet. And we'll shade that one in. So it's less than that line, and here we have them here. Now to find the region, some of you are crying out at the computer saying, well, it's obvious. It's where all 3 types of shading coincide, and it is, like we said, this area in here. Now, I personally would just label it R, and there it is. Now, you can't actually be on any of these parts here. So what you really should do is draw that triangle and then just dot around the outside, because it means you can't actually be on those parts, because there were no, for example, there were no greater than or less than or equal signs going on. If there had been, then you could do the whole region inside and on the outside. So that's the answer to that question. Sorry if that was a bit long, but I'll try to explain it in as much detail as possible. So if you see one again, you'll hopefully get it right. Just one extra point to notice is some teachers would probably not like what I said, because they'd probably want you to dash these lines for these ones, because they couldn't actually be equal to. I don't mind if my students don't, as long as when they do their final answer they make sure they're looking at the inequality sign to see whether it can be on the line or not. It's just like the locus questions. So you could have dotted all of these lines and made them like dots. I hope you know what I'm saying here. So you could just like make them all look like this. Okay, because they weren't supposed to be equal to the line. But that's just a minor point in my opinion. But if your teacher's told you to do it a different way, then definitely do it the way you've been taught. So this is quite an infamous question, and to be honest with you, I've not actually tried it. It caused a lot of controversy, but let's have a look. Hannah takes at random a sweet from the bag and she eats it. Okay, so that's non-replacement. Hannah then takes at random another sweet from the bag. She eats the sweet. The probability that Hannah eats 2 orange sweets is a third. Show n squared minus n minus 90 is 0. Well, the first thing that I would look at is this. This is probably the thing where I would start with. So the probability of having the first orange would be 6 out of n, because there are 6 orange sweets and n in the bag. And then the probability of picking the second sweet, if it's orange, well, there'd be 5 oranges left, but only n minus 1 sweets left, and that's equal to a third. So what I would personally do is do the algebra, so times those 2 fractions together. I would invert both sides. So the first thing I would do is do each to the minus 1, so I would have n over n minus 1 over 30 is 3 over 1, so that's just inverting, and then I would multiply both sides by 30, and that would give me n minus 1 equals 90, and then you can multiply this out and have n squared minus n. That would be equal to 90, and then just take 90 from both sides, and you can end up with the answer. Another thing is, once you get to here, so that's your first orange sweet, this is a probability for your second orange sweet, you can just do the same thing, and if inverting, i.e. finding the reciprocal of both sides, worries you, then just times both sides by 3 first, and you can have 90 over n minus 1 is equal to 1, and then just times both sides by n minus 1, and that will give you 90 equals n minus 1, so 90 would be n squared minus n, and then just take 90 from both sides, and there we have it. So the next part of the question says, solve this equation to find the value of n. Well, n is probably going to have a negative and a positive then, judging by what the question's saying with experience. So we want the positive one because there are numbers of sweets in the bag that you can actually pick. You can't pick a negative sweet, or negative number of sweets anyway. So we'll look at n squared minus n minus 90. You could complete the square, you could use the formula, but let's just look at factors of 90. So 45 and 2, we've got 9 and 10 for sure, and that looks like a good one because the difference between 9 and 10 could be perceived as negative 1. So we'll have n squared minus n minus 90. We'll set up a grid here, and we'll put in n in both situations. We'll put in the 9 and the 10 anywhere, it doesn't really matter, and we'll just multiply it out and see what happens, just assuming they're all positive. Well, we want a negative 90, so it means that it's either going to be this case here or this case. So let's say we went with that case first. We'd have the n times the minus 9, that would be minus 9n. This would be just 10n as it is, and this would be minus 90. This would be good then, that would be good, but these would sum to n, because 10n and minus 9n is just n, and that's not what we wanted. We want negative n here. So by deduction, we know that it was actually minus 10 here and plus 9, and then we have our two brackets, put them equal to 0, and it means that this bracket here times this bracket here is 0, which means that this bracket could be 0. Well, that's not going to be what we want because that would give n is negative 9, and that's not going to be negative 9 sweets in the bag. But this one will be just right, and we add 10 to both sides and we get 10. So I would say the answer is 10 sweets. So it doesn't seem too bad a question really. I think out of interest it's probably going to be useful to just look at the alternative ways and show why they may lead to more mistakes. So if you had n squared minus n minus 90 equals 0, and you wanted to use the formula, you'd have n is equal to minus b, so that's minus minus 1 plus or minus the square root of b squared, which would be 1 minus 4 times a times c. Now I say this because a in this case would be 1, b would be negative 1, and c would be negative 90, because you've got a formula really in n, an squared plus bn plus c is 0. So it's just like n is x. So, and then we've got all over 2a. So if we were to solve this one here, I guess there's a lot more room for error because you've got a minus times a minus, which is a plus, that's fine. And 4 times 1 times 90 is 360. But then this is a non-calculated paper, and then what will happen here is you'll get 361. If you don't know that 361 is 19 squared, well, you could be in trouble there. Or it might take you a little bit of thought. But you know that 20 squared is 400. And you know that 9 nines are 81. So the answer would end in a 1. So you could deduce that it was 19. Other numbers that times by themselves that end in 1. Well, if you think of all the numbers that times by themselves, the answer can end in a 1. Because 1 squared is 1. It can't end in a 2, not a 3, a 4, not a 5, not a 6, or a 7, or an 8, just a 9. So it's only numbers ending in 1 and 9 that, when squared, end in 1. So if you tried 11 squared, well, you should know that's 121, but that's nowhere near good enough. So it would have to be 19 squared, and that would give you 361. But all that aside, once you've got that, then you've got n can be 1 plus the 19, which is 20 divided by 2, which is 10, correct? Or n is 1 minus 19 all over 2, and you can throw that out straight away because it will be negative. So that's using the formula, and I don't know how many people would do that in this case. I might put a vote on this particular question, and people can vote what they would do. And then the last way, and if you don't want to watch this, then just skip to the next one. Complete in a square, add 90 to both sides, complete the square, add the quarter, and then you've got n minus a half squared is 360 quarters plus 1 quarter, which is 361 quarters. And then we've got n minus a half would be plus or minus the square root of 361 quarters, which is 19 halves. So add a half to both sides, and you get the same thing going on here as you did before. So I like completing the square, it's my favourite way, but I think I'd probably factorise in this case. And if I couldn't find the factor pair because I was nervous or stressed in the exam, then at least I'd have 2 other ways of a backup. You can't really just go into having one way, and if you have, then I'm sorry to tell you that you're going to have to, chance it then and hope that it works. But you really should have, at least 2 ways of approaching most problems in case one of them fails. And it will only generally fail because of stress in the exam situation. That's in my experience anyway. So let's move on. Now I've done plenty of questions on rearranging formulae, so I can try and put a link on this video. If I forget, then just look at rearranging equations. And I've got a couple of videos on those. One video is reasonably long, it's got some quite difficult ones in there to try. So for this one, we want to make A the subject of the formula. So if we write this out again, and I'll try and do this as many ways as possible. So if we multiply both sides by 4 minus a, what this will do is it will give us p lots of 4 minus a is equal to 3a plus 5, because the 4 minus a is the denominator part. And if you had a simple case where, say, p was equal to t over 5, then you would times both sides by 5 to make this denominator disappear from the right hand side, and you'd be left with 5p equals t for example. So we're doing the same thing here. Now, you may still be worried, thinking, well, hold on, I haven't got a on its own yet. Well, in this process, you just multiply out the brackets. You've got 4p, not p4, 4p minus pa. Now, the strange thing about maths is p4 was not allowed, but ap is. Okay, when you've got a number and a variable, the number always goes in front. That's just the way maths is. So in this situation, we've got 4p minus pa equals 3a plus 5. Now this is actually really good, because you could still say to yourself, well, a is not on its own. Well, if you get a on one of the sides only, then you can do something really good, which makes these questions really easy very quickly. So we'll add pa to both sides, and there's a good reason for that, because then we'd have 4p equals 3a plus pa plus 5. We're just going to take 5 from both sides, and that would give 4p minus 5 equals 3a plus pa. Now we're at a situation where this makes these questions easy, and it always happens at the grade A type of question and beyond. You've got to somehow factor something out. So if we look at A as our common factor here, we can say A lots of 3 plus P. You could say P plus 3 as well, that's fine. Just check 3A, AP or PA, that works. And then on the right hand side you've got your 4p minus 5 waiting for you. And then because this is multiplicative, i.e. they're timesing each other, you just divide by 3 plus p and do the same to this side because it's an equation, and you'll be left with 4p minus 5 all over, and I'm going to just switch these around, p plus 3 equals a. So that's one way of doing it. If we start the question and get to this stage here, then we'd have p lots of 4 minus a equals 3a plus 5. Again, multiply out. We'd have 4p minus ap equals 3a plus 5. And what I'm going to do this time is, and this is what could happen, and it's usually lack of experience that makes this happen, you could take 3a from both sides, and then you'd have 4p minus ap minus 3a is equal to 5. Then you'd have to take the 4p away, and you'd be left with minus ap minus 3a equals 5 minus 4p. And then you can do a nice thing here. You can times everything through by -1. So you can times everything through by -1. And that would give you a plus here, a plus here, a minus here, and a plus here. That's fine to do. I use that a lot with simultaneous equations. And then you can factor the a out, and you'd have a lots of p plus 3 equals. Now, generally in maths, you don't generally leave a negative number leading the expression. That's when you get to a more higher level, you'll see that pattern appear quite a lot. So you can write minus 5 plus 4p and then divide both sides by p plus 3 just like before. And that's perfectly okay, but I think most mathematicians would just write the positive part first and then this, and they would be the same. There's a couple more ways of doing that question, but I think those two ideas are probably enough. Just think of factoring or factorising at this higher level. That's generally always going to come in if it's an A or beyond. Okay, let's have a look at another question. Well, this type of question, again, there's a few approaches you can take. A nice systematic approach, which is not very stressful, is to just write down the recurring decimal and just times it by 10, and you would just have 0.45 recurring, and then just times it by 10 again, and you'd have 4.5. Now think, this would carry on here as 0.454545 and so on. So there'd be a 4 here, and then there'd be another 5, then there'd be a 4. So really the part that recurs after the decimal point would be written like that. And then if you do 1000x, i.e. timesing it by 10 again, you'd get 45.45 recurring. Now the nice thing about that is that if you compare these values, you've got 1000x, 100x, 10x and just 1x, if you can do something to two of these equations to get what's ever after the decimal point to disappear, it's not a trick, it's just pure maths, then we're onto something. So I definitely would look at this one here and this one here because they have the same decimal part. So if I do 1000x take away 10x, that means I'd have to do 45.45 recurring take away 0.45 recurring. And that's nice because this part will just vanish and you're just left with 45. So on the left hand side you've got 990x, and on the right hand side you've got 45. So you can write that as 990x equals 45. Divide both sides by 990 like you would in any linear equation, and you'd be left with x equals 45 over 990. You haven't got a calculator, so you've got to show that it can be written as 1 over 22. So if you know that this is where you're heading, then what you could do is just divide top and bottom by 45, and then that would lead to 1 over 990 divided by 45. And if you could show that that was 22, i.e. 22 times 45 is 990, and you'd only have to do a simple multiplication question to do that. So we times that by 45, and we get 8 and 8 and 10 and 10. So that would give us the 10, 18 and 1 is 19, 8 and the 1 is 9, that's 990. That would be good enough. Or, this is the nice thing about number, if you had x was equal to 45 over 990, you can use your prime factors or any type of factors of 45 that you know. So you can make that 5 times 9. You know this is 99 times 10. Now, if you don't like that, if you can't see that 5 over 10 is 1/2, then don't worry about that either. You can just write the top out again. And the bottom part here is 9 times 11 times 2 times 5. And then look for things that cancel. And then look, these cancel to give 1. These cancel to give 1. So what you're left with is 1 over 22. So that's how I would approach that particular question. So for part A, we want to find the value of 2 to the negative 3. But if we look at 2 to the power 3, that's 2 times 2 times 2, which is 8. 2 squared is 4. 2 to the power 1 is 2. notice these are all being halved. So the next one's going to be 2 to the 0. Anything to the 0 is 1. And then halved again. And then half of a half is a quarter. So we're going to get 2 to the minus 3 is 1/8. It says 5 root 5 can be written in the form 5 to the power of something. Find the value of k. Now, if we write this as 5 multiplied by the square root of 5, then square rooting is the same as writing to the power of a half. So if you had 5 cubed, for example, and you wanted to write the cube root of 5 instead, you would write 5 to the power of a third, and that would be the same as this. This notation's not used as much as this. So back to where we were, this is the same as saying 5 to the power 1 times 5 to the power a half. And by the rules of indices, we can add these powers, and that should give us 5 to the power 1.5. That would be okay, but I think it's nicer to write 5 to the power 3/2. That's generally how it would be written at higher level GCSE and A level. So there we go, 5 to the power 3/2. So k was 3/2, just get that written down as well. Now, we've now got to work out the value of something in a bracket all squared. So my favourite way of explaining this to people is to do it in a grid. In this case, you've got root 12 times root 12 is just 12. You've got negative root 3 multiplied by negative root 3. That's just going to be 3. So we've definitely got 15. So for this part here, we're going to have positive root 12 times negative root 3, which is negative root 36. And here we're going to have a negative times a positive, which again is negative root 36. Now they don't cancel out. The square root of 36 is 6, so this will be the same as writing negative 6, and here will be negative 6. So you've got your 15, and you've got to take 6 away from that, which would give you 9, and you've got to take 6 away from that again, which would give you 3 as the answer. Now, there are other ways of doing this question, and one way is this. You could take root 12, put it in surd form, and all that means is finding square factors, so you write the square numbers down somewhere. Look for the highest square number that goes into 12, which is 4, so you can write it as root 4 times root 3, and you know the square root of 4 is 2, so you'd have 2 root 3. So you'd end up with 2 root 3 minus root 3 squared. Well, 2 lots of root 3 with 1 lot of root 3 taken off is just root 3. And if you square that, there's 2 ways of thinking about it. Yes, you can see it's 3, or you can see it's 3 to the half times itself, because this is the same as writing 3 to the half, and this means times by itself, or square. And if you add the indices here, the powers, you'll get 3 to the power 1, which is just 3. So there are quite a few ways of doing that question, but there's 2 ways for you. So this question here is very difficult in my opinion. It says the container is a cylinder on top of a cone. The cylinder has a radius 3 and height h, and the cone has a base radius of 3, so we can put that in here as 3 also. And the cone has a base radius of 3 and a vertical height of 4, okay, as opposed to a slant height, which that would be. So a vertical height, i.e. going straight down. The container is empty. The container is then filled with grain at a constant rate. I think this has to be the key to the entire question, constant rate. After 5 hours, the depth of the grain is 6 meters above the vertex of the cone. After 9 hours, the container is full of grain. Work out the value of h. Right, so let's really try and split this problem down because it's even worrying me a little bit. So I think the first thing to do would be to work out just how much volume had been taken up after 5 hours. So we know it's 6 meters above the vertex, and this is the vertex of the cone. So we know after 5 hours we've got 2 more meters here. So the volume of a cone I remember as 1/3 of the volume of a cylinder that occupies the same space. So that's 1/3 times pi r squared h, and you can look at that on the formula sheet. What I'm basically saying is if you had a cylinder, and I've said this before on a paper, and you want to draw a cone, if it occupies the same height as the cylinder which you started with, then 3 of those cones will fit into the cylinder in terms of a volume. So you just have to know the volume of a cylinder and divide by 3. So the volume of the cone that would be filled with sand at least, because the 4 meters worth would be done, would be 1/3 times pi times the radius squared times the height, which is 4, and then this would cancel and you'd be left with 12 pi, and that would be 12 pi meters cubed. And then you've got another 2 meters worth of cylinder to go. Okay, so if that's the cone here, then you've got the volume of the cylinder would be pi r squared h, and pi times the radius squared is still 3 squared times the height. In this case will just be 2, because we're just trying to see how much is filled in 5 hours. So that's going to be 9 times 2 is 18 pi. So we know after 5 hours we've got 18 and 12, and this is meter cubes as well. We've got 18 pi and 12 pi, which is 30 pi meter cubes is full. Okay, that's how much sand there's going to be in there, 30 pi meter cubes worth. Now, personally, I think it's not too bad now, because if you've got this constant rate, that means the sand is going in at the same rate, and that will be so many meter cubes per hour or minute or so on. Okay, but it's going to be constant, it's always going to be the same. So we know that in 5 hours it did 30 pi worth of volume. So that means in 1 hour it would have done 1/5 of that. It would have done 6 pi meter cubes in 1 hour. Just divided both sides by 5. So 30 divided by 5, that is 6 pi. So in 9 hours you've got 4 more hours worth. So you've really got another 24 pi meter cubes to go. Okay, now that is how much volume this part, what's left, should be. Okay, and we can work out what that is in terms of H, because the volume of the cylinder remaining, and I'll put that as REM for remaining, would be, well, pi times the radius squared times the height this time. Well, if all of this was H and 2 was taken off it, then what's left here is, I'll put this in the colour here, this part here would be H with 2 taken off, so H minus 2. And the nice thing about that is we now know that that is going to be equal to 24 pi. So we can cancel pi from both sides by dividing both sides by pi. We can do 3 squared times H minus 2 equals 24. I personally would multiply out now the brackets, and I would get 9h minus 18 equals 24. So I then add 18 to both sides, and I would have 9h equals 42. So h would be 42 divided by 9, because I divide both sides by 9. I should have really put that in here. So if h is 42 over 9, then you can leave it at that, but you should know that 3 goes into 42 14 times, and 3 goes into 9 3 times. So this cancels, and you're left with a seemingly wrong answer, because I'd be worried about that, to be honest, if I was in the exam. But I don't think we've done anything wrong here, because we abided by this constant rate issue here. So we knew what it had done in 5 hours. We knew it had to go all the way to 9, which was 4 hours. We worked out what 1 hour was, so we knew what 4 hours remaining would be. And we definitely got our formulae correct. So there's nothing wrong there. So it looks wrong, but I'm pretty sure that that is the answer, 14/3. So here we are, we've arrived at the last question of the paper, and a question I've been dreading, not because I find these questions difficult to do, but they're very hard to explain. And I do promise you that I'll be doing a video on transformations, which I'll put a link to on this question, so you can look at it at a later stage. It's taken me 7 or 8 attempts to try and do a video on transformations, but every time it's been too much for me to do, so I'm going to have to really have a think about it. So let's have a look at this question. We've basically got to transform the graph given by, firstly, the rule y is equal to f of x plus 3, when we're given that the equation is y equals f of x. That's actually drawn. So, and we've got to write down the maximum point each time. So for this one, the first one, I hope you'll notice that it's in the form f of x plus a. Now, if I do that type of transformation to a graph, I actually do a translation. So here's a little bit of an explanation. Let's take a graph y equals x plus 2 times x minus 3, for example. And if I multiply that out, I'll have x squared minus x minus 6. Now if I call that f of x, then it doesn't really matter which form I look at, because the graph would be the same. In this form you can see that the intercept is clearly -6, and it would have this type of shape. Now from here you can see the roots will be -2 and 3, otherwise known as the solutions. And the point I'm trying to make is, if I was looking at f of x, and I think in the question, if I remember rightly, it was f of x plus 3, then one quick way of looking at this, don't forget I'm going to do a video on this afterwards, is to rewrite the original one, say here, but instead of writing x, you just write x plus 3 in its place. So instead of writing x, of course, you just write x plus 3 in its place. And then what does that give? Well, you'd have x plus 5, and you'd have x. Now, if you were to put that function here equal to 0 and find where it cuts the x-axis, you'd have the corresponding solutions x equals negative 5 or x equals just 0. Now here's the thing to help with this question, and I'll just change the colour of the pen here. And that is, before we did anything, we had x was equal to negative 2. But then after the transformation f of x plus 3 in brackets, we seem to have x is negative 5 occur. So hopefully you can see that the x coordinate here of one of the solution points has just moved back by 3. So it seems to do the opposite to this sign. And if you look at x equals 3 here in the original, when you transform it using the form f of x plus 3, where x plus 3 is in the bracket, then your transformed solution point becomes x equals 0. So that's one little idea to see that in this question here, we're just going to say that the maximum point here, 3, 5, all that's going to change here is the x value is going to become 3 less, so 0, and the y value is going to stay the same. Now, if you actually plotted f of x, which I'm not going to do now, which we started with was x squared minus x minus 6, and you plotted f of x plus 3, which gave us x plus 5 lots of x, which if you multiplied out would be x squared plus 5x, then I can assure you that the lowest point, the minimum value, would not actually change. So the y value doesn't change. Again, that's not a brilliant explanation. This is why I said I was going to do a video in parallel to this question, and I'm going to put a link on there. So they're the ones to watch out for. So if you had f of x minus 7, then all the x values would move to the right parallel to the x-axis by 7 units. But in this case, like I said, we just moved to the left 3 units parallel to the x-axis. Now, the second part to this question here is where we're given y equals f of x drawn for us, as we have shown in each case here. And all we're doing is we're multiplying this function by 2. So one easy way to think about it is if y was equal to f of x to begin with, then what we've done is we've actually said that y now is going to be twice as much as it was before. Now I can go back to my example here, so I'll have to just minimize the whole thing. And if I said my original was y equals, and I think we had x plus 2 times x minus 3, if I actually just said to myself, well, I'm just going to make it twice as much, so I'm going to times the function by 2, then this 2 could multiply into the first bracket and give me 2x plus 4 times x minus 3, or it could multiply into the second bracket. Can't multiply into them both at the same time because then it'll be timesing everything by 4. So we could either have x plus 2 times 2x minus 6 or 2x plus 4 times x minus 3. Now one thing I want you to notice is that if I put those equal to 0 to see where the solutions were, in the first instance, in this part here, if I put the first bracket equal to 0, I would have 2x plus 4 equals 0, which means that 2x would be negative 4 and x would be negative 2. Just like I'd have here in the first instance. And then if I solve this one, x minus 3 equals 0, I would have x equals 3, just like I did here. In fact, if I solve 2x minus 6 is 0, I'd have 2x equals 6 or x equals 3 again. So what's actually happening in this situation is it's not so much the x values that are changing here, it's only the y values. And like I said, you deserve a better explanation than that, but this is just a quick reminder here. So our maximum point in this case, the x value would stay the same and the y value would double. And this brings me on to the most difficult type here. So we're going to give it a go with my original, so sorry about all of this mess here, but let's try and have a look at our favourite one here that we've chosen every time, and we had x plus 2 times x minus 3. Well, if we say that we want f of 3x, then what that means is, so be very clear on this, if this was f of x, which was where we started, and by the way, for some of you that have just joined in halfway, this expression here is just something I picked out of the air. It is not this graph here. I'm just using this one as an example. Okay, so we want to say, we want to get to the situation where we've got f of 3x. So what we're saying is x has actually become 3x instead. So whenever we write this here, we're just going to substitute x for 3x. So we're going to have 3x plus 2 multiplied by 3x minus 3. And if I multiply that all out, I'd have 9x squared minus 9 plus 6 is minus 3x minus 6. So one thing you might be able to notice is that if I multiplied out the original before I did any transformation at all, I'd have x squared minus x minus 6. So I think you've noticed that the intercept here has stayed exactly the same. If we compare the solution point, so say if we put them both equal to 0, here we'd have x equals negative 2, here we'd have x equals 3, and in the transformed version here, if we put this equal to 0, we'd have x equals minus 2/3 and x equals 1. So I want you to really focus here. Now, if we pick on this one here, this is where we started, and look where we ended up. The x value had become 3 times smaller, a factor of 3 times smaller. In fact, if you times 3 by 1/3, you actually get to 1 where you ended up. Does it happen for this x value here? Well, we're starting at negative 2, we're timesing by 1/3, and we're ending up at minus 2/3. So what we seem to be having here in this situation, and like I said, it's not a brilliant explanation, but I'll have to do for now, is when we've got a situation like f of 3x, what we're actually doing is we're dividing all the x coordinates by, or I should say ordinates, or the x ordinates by 3, and we're leaving the y's completely unchanged. So in this situation we had the maximum point was 3, 5, and we wanted to do this transformation here. So what we did is we're actually just dividing all the x component parts by 3, so 3 becomes 1, and the y values stay exactly the same. Now the last part of the question says the curve with equation y equals f of x is transformed to give the curve with equation y equals f of x minus 4. Well, one quick and easy way to look at this is if you have y equals f of x and you're comparing it to y equals f of x minus 4, then what's actually happened is to every point that is plotted, everything is just translated downwards by 4. If you had a situation where you wanted y equals f of x plus 2, for example, then every point that is plotted would just translate upwards by 2 units parallel to the y-axis. So we can have a little example here. If we had y equals x, which we looked at in that reflection question earlier on, and we just graph that quickly, then if we look at y equals x plus 1, then what's happening is the intercept just moves to here, the gradient stays exactly the same, it's still 1, and we just get a line that's parallel to it, so all the values have moved up by 1. So in this case, whether you've got a straight line or a quadratic, I think that look like this, all that's happening is that all the points are moving downwards by 4, and the best way of saying that amongst all this mess is to say that the x coordinates stay exactly the same and the y coordinates all go down by 4. So if you had your original graph here, then all we're saying is we go down by 4 units and we have the graph here, and this distance from any point you choose is always going to be the same. It's going to be 4 units each time. Okay, so that's the end of that paper, and hopefully you did okay. The idea here is to try and do some of the questions first and then try and look at the explanation. Also, I suggest that you come back to this paper in a couple of weeks' time and try some of the questions again, just to kind of reinforce some of the points. I think the more you practice a certain type of question, then the easier it becomes. So I'll try and put as many of these papers on as I can. They do take a long time, but I think it's definitely worth doing.